right, here we go. All right, I'm going to do more of an interactive presentation. So if you guys got any questions or anything and want to stop me while we're doing it, feel free. It's totally fine. So first thing we're going to look at is what is a smart space? A smart space is basically, it's a space designed to prioritize human needs and experiences, such as going into your home, going into workspaces, anything of those natures. They're technology integrated. They have lighting control systems, occupancy sensors, temperature control, air quality monitoring, AV control, network access, access control, and surveillance systems. They're basically designed to help make the spaces more comfortable and productive, and all with an easy-to-use interface. And so some examples of these would be for your home. You know, you have Google Home or Alexa and lighting control and all the little things that everybody wants that, right? Turn the lights on, turn the lights off, start the pool, whatever it might be, you know, turn the temperature up, turn the temperature down. Most of the devices in these smart spaces are PoE, which is power over Ethernet. And so this gets into the infrastructure side of things more, is where kind of I'm going with my presentation, because that's what I do. I install the wiring for all these devices and make sure that buildings and homes and everything are ready for the future. Smart homes, according to a CES 2024, they announced some research showing that the average number of connected devices per U.S. internet household reached 17 in 2023, which is pretty high, because that's an average, right? So there's going to be a lot of people that don't have any, and there's going to be a lot of people that have more. So 17 devices, I mean everything from your refrigerator to your cell phone to your iPad to water sensor, water meters, sprinkler controllers, pool controllers. And then the smart office space, this is where mostly I work in for the construction of new commercial buildings and everything. And so it's a very growing market. It is estimated in 2024 to be a $51 billion industry, and it's expected to reach up to $97 billion by 2029, which is, I mean, it's a huge increase. Part of the things that are driving that growth too is after the pandemic, people have started working at home a lot, and you have a lot of mixed work environments, and people want to get people back to the office. And so one of the things they're trying to do is design these spaces to be a little more user-friendly, right? Why do you want to go back to the office when you have all your stuff at your house and everything like that? But that's part of the big push that we're seeing, at least out here on the commercial buildings that we're doing, is just more conference room spaces and office spaces. Raise your desk up and down. People can control all the creature comforts that they want in there. And then there we go. Smart cities. I don't get into that too big. Rena just did a great job on that. But one of the things I briefly looked at was this city that they're building in Saudi Arabia called The Line. I don't know if any of you guys looked at that before, but it's pretty crazy. They're talking about it, I think, forgive me if I have some of the facts wrong, but they're looking at like 150 kilometers long, stretching from the sea, and they're talking of having upwards of like 9 million people live in this smart city, essentially, which, I mean, it's pretty cool. But as you can see, it could probably be very well used as a prison as well, right? Once you get, did they reduce the size of it? Okay. Yeah, there's a pretty good thing. It's Neom. They got some interesting videos on it if you want to watch it. It's pretty cool. But I'm going to get more into the infrastructure side. I'm just kind of brief overview of this. I got this presentation as somebody quit or didn't show up or something, and so they asked me to do this kind of last minute. So I'm trying to tie my stuff into it, and so Forgive me for that. So, according to the S&P Global, AI smart cities are underpinned by pervasive digital infrastructure, including connectivity and compute resources to support the collection and analysis of data. Connectivity can vary through most cities, though most cities rely on a combination of cell networks, Wi-Fi, and wide area networks. These networks provide the data highway between the information collecting endpoints and the cloud, where the data is often processed and acted upon. And so that's where I come in. You want to put in these sensors and everything, I'm all for it because I have a business selling cable, right? Installing the devices. Now, the importance of having good cabling infrastructure, as you know, the communications wiring, your fiber optic, Cat6, this is the highway that your data runs on. So you can look at bandwidth as kind of a as traffic as you would on a highway, right? The higher bandwidth you have is more like a 6, 7, 8-lane freeway, and lower bandwidth applications are, 2-lane road with a bunch of potholes, things like that on it. So it's important to have good infrastructure for what you're doing, and this goes back to the cost thing that Rena was talking about. With your lights and everything, you got to do an immense upgrade of infrastructure in order to get those to work. Now, I imagine a lot of it's going to be going cellular soon and wireless technologies, but you still have a lot of infrastructure that goes along with those things. You can look at some of these. I don't know if you guys are in a lot of IT closets, but I get in a few of them, and a lot of them I see look like this guy right here and this one. So, and you can imagine as doing an upgrade or installing new systems, these type of things make it very difficult for the installer from a troubleshooting standpoint, or just adding new cable just because of capacity. So one of the things you want to do is kind of keep a major free rate, which is this, like this, something that's organized. And the important thing of that is you want to kind of future-proof what you're doing. Because the technology that are going into these buildings, I mean, the life cycle of your cable is typically about 15 years. And so just think about where your tech was 15 years ago, right? Now imagine where it's going to be 15 years from now. There's only going to be more and more sensors, more and more things, more and more things going on your IP network. And so important things to remember are having access to that. For example, in this building above this drop ceiling, well, I don't know about this one, this building's pretty old, but there should be cable tray or some way to access new wiring for this building. And so that's one design consideration to really keep a hold of when you're looking at implementing some of these systems, because it gets pretty crazy. You could have 48 devices in a room really easy, and that takes up an entire patch panel, an entire switch in an IT closet. So you've got to plan for that. Types of cabling, you got copper cabling. Cat6, Cat6A is basically the standard right now. They have some other ones out there, but they're really not in high use yet. Fiber optic cable, it's been around forever. There's been single mode and multi-mode. Most things are going on single mode cable now. Reason being is your bandwidth is virtually unlimited on it. You used to have the limiting factor on your fiber optic cable was the cost of the transceivers. And so single mode was a lot more expensive. They used different lasers than you would on the multi-mode. But the price of electronics has come down so much that it's really not an option or a consideration anymore. So it's best just to go with single mode. It really keeps your stuff open. Cat6, you can get up to 10 gigabits a second for up to 55 meters. Cat6A, you can extend that out to 100 meters, 10 gig a second. So you get pretty good throughput. Fiber optic cable, as I was mentioning, is virtually unlimited. You see a lot of multi-mode stuff being used in data centers and things of those natures, where they're using small form factor connectors where they'll have actually 10 fibers in one device, and some of those links, they're getting 100 gigabit links in a data center, which is pretty big. Fiber optic cables used for backbone, Data centers, long-haul transmission, basically anything on the side of the road is usually going to be fiber optic going from one side to another. All the copper infrastructure is basically getting obsolete. Pathways. This is where I was talking about the stuff in the ceiling. Pathways are one of the most important considerations for design, and that would be anything like your cable tray, ladder rack, your conduits that you're putting in spots. You really want to keep that at about 40%. So if your initial install, to kind of future-proof yourself, you want to make sure your fill ratios and everything on that are 40% to allow for future growth. So it costs a lot more money to design your pathways to have a good solid thing for the future, but it definitely will pay off. As you can imagine, coming into a building like this that had no old infrastructure, running that is a real nightmare. Just from an operation standpoint, you got to close down some areas of the building. You got to put new supports for weights of the cable. I mean, it really adds up quickly. What are the goals of the smart space? They're to do comfort, usability, production, convenience, enjoyment, analytics. And I think that everything basically comes down to that analytics, and that's where the whole AI stuff is going too, right? You want those sensors to be there so that you can get information, so that you can make changes on the fly and make different energy efficient things, or, to monitor you and stick you in jail. You never know. But with all, I mean, things, privacy concerns are a major thing on it. It's all the convenience are great. Like I use Google at my house, I love it, but I know that they're listening to me, right? You use your phone, and you ever get on Facebook or something, all of a sudden they're marketing to you with something that you were just talking about, and you're like, I didn't look this up, but. So imagine what that data is going to be worth once they have everything that you're doing, where you're walking, what you're doing. So next, we want happy people. So I had to throw this slide in there. It's just everybody happy and shiny and good. Some of the takeaways I want everybody to get by with is just to make sure that the infrastructure is not if you have a design project, the infrastructure is not an afterthought. If you need help, call a professional. Make sure they're qualified, make sure they have BICSI credentials. BICSI is like a governing body that writes standards and codes and all that kind of stuff for the data transmission industry. So if you got any big stuff, look for somebody that's got that, and usually you can't go too far wrong with them. Make sure they have verifiable experience, and typically guys with BICSI do. You have to have some of that to get those credentials. Plan on the cabling infrastructure to be used for a minimum of 15 years. That's what I said before. Just make sure that, think back 15 years, think ahead 15 years, and see where it's going. Pathways and future cabling needs matter, so just keep that in mind. And that's basically my presentation. I kept it a little bit short and sweet, so open it up for any questions or anything you guys have. If not, I'll get out of your hair and we can get out of here soon. Yeah. So some of the worst ones I've seen, actually the worst one I've seen was there was a wiring closet at the University of Montana, and it was in Main Hall, and Main Hall is like, it's been there since it's like the late 1800s is where the building was. So there was and it's a historic building. We had to run new wire in it, so it was just a nightmare just doing it. But then it's on the historical record, so you have all this. You have to just get a hold of the city and the people in the university and everything just to go through, just to put a hole in some of the stuff, and yeah. So it's fun, and there was a lot of the buildings on there that are similar to that, but there's some bad ones out there for sure. Anybody else? Yes, sir.
Where do you see the future of cabling? Like, what the current newest technologies coming out?
Yeah, so wireless is huge, but there's a lot of wire that goes behind the wireless. Everything is going wireless, and I think with the advancements in robotics and everything like that, the strength of your wireless network is really going to be the thing that really determines. For example, we did a warehouse, and in that space we have 190 access points that we put in. Each access point got 2 Cat 6A cables going to it, and the Cat 6As run they're all power over Ethernet, right? So that's powering the Wi-Fi. But in the space, they have this thing called the auto store. I don't know if anybody's familiar with that, but it's basically a storage facility within there for little parts, and it's got big bins, and then there's all these robots that go back and forth, up and down. They grab parts, and I'm doing a bad job describing it, but they move the parts and brings it out to a person. Anyway, it runs on the wireless network. Pretty much everything is going to run on the wireless network, at least in the in like a warehouse type setting. Now, as you get into buildings, more like in here, everything's going to be kind of PoE. So the wiring is necessarily not really changing a lot. They kind of the nice thing is they kind of standardize on these wiring, and everybody kind of designs their products to work over Ethernet, right? You can imagine if everybody had their own proprietary cable and everything like that, it'd be a nightmare to try to sell. But so the wiring technology is not super crazy as an advancement. The advancement would become in the devices that are going on the wireless. The biggest things I see that's going to be a market disruptor, especially for us, is going to be PoE lighting. And so typically lighting was all 110 volt. Now a lot of the lighting is LED, and the power is low enough where you can drive that from your actual network switches. And so instead of getting an electrician to run your light, you're actually getting a low voltage technician to run a cable to your lights, and part of that goes with, so every light can be monitored, right? As you have an occupancy sensor on each light. As you walk by it, it turns on, much like you're talking about on the outside, but they're doing that inside the buildings as well. So that's the biggest thing that I see. And so you'll see the cabling push go to Cat 6A, and the reason you go to Cat 6A is because the wiring gauge is bigger than Cat 6, right? And so you can transfer not only more data on it farther, but you can transfer more power on it. So you're going to see a lot of stuff going more to power over Ethernet. You're going to see a lot of outlets in walls that were 110 volt. A lot of those are going to be going away, and they're going to be going to charging ports that run over PoE as well. So instead of having to run that 110 down the wall with an electrician, you can use a low voltage guy that comes in as they're running the wire for your access points, security cameras, everything else, run that outlet, and instead of having a 110 plug, you'll just bring your cord with you and plug into like a USB-C outlet on the wall. That's powered by power over Ethernet to the switch. That gives everybody a little more basically control over everything, right? You can turn power on, you can turn power off, you can monitor everything on the network. It's monitoring how much power output's going to the lights, how much power outlets go into the devices on the wall. So it ends up being a real convenient thing, but at the same time, it's something that you're really monitored and tracked by. So it's one thing. It's just got to be privacy concerns, but that's the biggest push that I see coming with the power.
I did not know that. That's fascinating.
Yes. Yeah, so it's pretty interesting. It's all cool stuff. I love being in tech and seeing all the new things coming. So I'm pro tech, but at the same time, I'm kind of pro freedom and pro I run through all kinds of scenarios in my head where, what am I like helping build my own demise? Yes.
So the outlets that you were referring to, are they different from the ones that are available now?
No, that you can get.
That's going to be more widespread.
It's going to be more widespread, yeah. So there'll be some electrical changes that are going on where right now they have to have outlets so often, right? And a lot of it's for devices, but they're looking at reconfiguring some of those.
So the foreseeable future, cables are going to be here as well, what I'm hearing as well. Like your Cat 6A, but
Yep.
for the foreseeable future, you will have cable.
Oh yeah, absolutely. You'll have cables definitely within buildings because you're going to have to power those devices.
And I say that because so many of my clients, and this is like nationally, we talk about this push to the cloud and
Hmm.
getting off of, let's say, any on-prem type of connectivity.
Right.
But I just don't see adoption, an overwhelming adoption of completely going away from Ethernet, like on-prem Ethernet.
Oh no, not at all. Because that's your power supply too, for your devices, and then you'll probably see a lot more of that. Definitely, a lot of more people are moving their stuff to the cloud for sure. But it's in that. So the ISPs, the internet service providers, that's where your bottleneck's going to be. So you still need a large data transfer, from PC to PC on your network, but it needs to hit the cloud and then come back to you. So you're probably going to see a lot more. You're seeing a lot more fiber to the home and a lot more fiber to the business pushed that way, and that's the reason. There's a company here called Switch, which is a huge data center. I don't know if anybody's familiar with Switch, but they have one here in Reno, and they're all redundant systems, right? But people need that's where your cloud lives. Not all of them, but a lot of your infrastructure is on that. So you're
They're pretty cool. Like
oh yeah.
they cool their servers like using reusable like water and cooling vents and whatnot. And it's like they're mobile. So you can move these data centers from Vegas to different places in the country so that you can have different data points and get your data closer to the area.
Hmm.
Because ISPs, though you can move these packets of data, you can move them a lot faster. It still slows down once it gets
Yep.
to the premise of the customer. So, but they're pretty interesting.
Yeah. So that's the big bottleneck is basically at your incoming connection, right? And then cross-country traffic, and depending on the network. Yes, sir.
Is your company threatened by AI? Like, you see a particular job going away?
I'd like to say no. That's what I'd like to say, but I don't know. I think it kind of it will be determined by the advancement in robotics. Because once, I mean, you got to understand the labor pool that, especially here in Las Vegas, everybody is a union labor, and not everybody, but the labor is very expensive. And so with anything that's very expensive, you're going to be trying to push and figure out how to get away from that. And I mean, it makes sense from a productivity standpoint, and then these jobs can run all night long too, right? You just got your little robots, got to charge them up. So I'd like to say no. I don't think plumbers or electricians or low voltage technicians are going away anytime soon. But if there's some kind of crazy advancement, I don't know. I could definitely see a reason and an incentive to get rid of those type of people, right? Because they're expensive. And so maybe it goes down to,
Would you say it would continue being a high-paying profession? Yes.
I think so, yes.
Okay.
Yeah. The trades are very good, as you mentioned, the plumbers.
Trade, right?
Yeah, it's a trade, yeah. Yeah.
Yeah, okay.
So, yeah.
Just trying to like figure out which jobs are going to be good for the next.
Right. Yeah, I think for the next while, you're going to be pretty safe in the trades. But I try to tell my kids to try to get into the trades or something because it's a great option. And there's a lot of people that just don't want to do it. But those jobs are kick butt. They're starting out probably $100,000 a year. So.
You got to just tell like people, give them the example of the last time you brought a plumber to your home. You didn't pay less than like $150.
Oh yeah.
You're going to be there for like 20 minutes.
Yep.
So,
No, it's yeah. Around here, I mean, I'm sure it is everywhere, but Vegas is a very service-oriented town, and so everything's a service. The eight.
I'm catering, so in that new profession that you it's a big like come train with you.
Yeah, absolutely. Come on, we're always looking for somebody.
So do you with AI? Do you get and with the cabling? Do you get more? So there's a lot of conversations about 5 nines of reliability, right?
Mhm.
What five nines is being reliable, being up on your internet 99.9999% of the time, right? Which means roughly you're down like 5 to 9 minutes a year is an outage that you're seeing. The closest anyone comes to that is like Amazon,
Right.
and they don't even get it. Needing that level of reliability and uptime, do you get more requests for cabling when you deal with larger customers that are using like giga centers, like a Google might have to move a lot of that AI data?
Yeah. So a lot of things they do is they put a lot of redundant systems in their networks. And so, for example, this warehouse that we did, that's a big automated facility. We have a double backbone for their fiber, right? And so what that means,
Yes, sir. Double backbone sounds like a meal.
right, it does. Sounds like a good one too.
What is it?
So double backbone, you got a fiber optic backbone running from your main server. Say you have a server farm on this side of the building, you got a server farm on this side of the building. You have one backbone running from this one to, say, an IDF cabinet to service, your devices out in the field, and another one over here. And they do that basically in case something happens or gets cut in this. If this line gets cut or damaged or they have something go on, all that network traffic can still just route back around the other way and still service those. Yeah, basically like a failover, right? And then they'll put redundant power systems in there for your UPSs and everything too. You'll have an A and a B circuit for that. And so it'll, you have one panel feed from the other, one side of the building, one panel feed from the other. And if one goes out, your power just kicks right back over. And you have UPSs too for your backup that'll last, 20 to 30 minutes usually is what you're seeing. So depending on the size of the facility. But yeah, there's some crazy stuff out there. That 99% uptime, you have some data centers, and I forget the exact terminology for it, but it's like N+2 or something, right? And so you can have pretty much any system go down and everything is still running, right? It would take a major catastrophe to knock down the whole thing. So, all right. Well, thank you guys. I appreciate it.
Thanks for filling in.
Yeah, absolutely.